Good morning, everybody. Today, we're answering the question, what is a layer 3 switch? And how's that different from a router? Well, the quick answer is a layer 3 switch is a switch that can also route. And you'd probably use it to route between your own networks, as opposed to a router, which you'd probably use to route between you and the internet. Want to know more? Stick around. Let's get into it. So, if some switches can route, what's the point of routers? Really, it's mostly a marketing distinction at this point, but an important one. And it's basically down to your expectations about what you are buying if someone has marketed something as a layer 3 switch versus marketing as a router. And it goes back to what we said. Is it, generally speaking, something you're going to want to put between you and the internet or between your own network? So let's do it here. I think Tiny Brian. Yeah, Tiny Brian. All right, let's get to drawing here. So actually, before we even draw, let's just type some of this up here. Let's make a list. So a layer 3 switch, or L3 switch, versus a router. Yeah, and so sort of the things that you would expect if you're buying one of the two of these. A router, you would expect, like we said, to put between you and the internet. So it's going to have almost certainly some sort of non-Ethernet interface or port. Yeah. Some classic WAN port. A bunch of years ago, this might have been like a weird 30-pin serial connector. It might have been T1, T3, DSL, a cable modem, DOCSIS, right? Any of those things would have been possibilities over time where there was literally like a module on like a hole on the front of the router, and you would buy the right card to slot into there to connect to your internet service provider. So some non-Ethernet port. Today, really often you're handed Ethernet, but maybe a cellular connection. Yeah, like your 5G connection or something like that. Either as primary or a backup connection to the internet. So some non-Ethernet port between you and the internet on something you're buying that's sold as a router. Also, generally speaking, there's exceptions, but generally speaking, you would expect all of the ports to be routed ports by default. Okay, routed ports by default, which is to say that the ports on there would not just be the ports that you would just put into VLAN 1, VLAN 10 or something like that and have, these 15 ports are on VLAN 10, those are in VLAN 20. Instead, very generally speaking, each port is likely to be something that you just put an IP address directly on. Now, there's exceptions for sure, where there's like a switching module with like 12 or 24 or whatever ports in it that you could set up like a normal switch. But most of the ports on there would be routed interfaces by default, very likely. You would also expect NAT, network address translation. We're not getting heavy into that here. But the short answer for what the heck is NAT, or network address translation, is this idea of being given one IP address, maybe a few, by your internet service provider, and that being your public address, whereas all of your machines behind the router have private addresses. And you're translating that network address so that all of your private addresses on your computers behind that router, all of their traffic seems to come from your one or few public IP addresses. A router, you'd expect to have that. You would also, very generally speaking, expect not super fast ports, probably, compared to an Ethernet switch anyway, right? 10 gig is on the faster side for sure for what you'd expect on a router. They're definitely faster ports, but it's just your internet service provider, even as a pretty big company, you're not likely in a lot of cases to go past 10 gig connection for Ethernet. It certainly could be, right? But in a lot of cases, probably not. Okay, so let's jump over to our layer 3 switch. So this, I would expect all Ethernet ports. There's exceptions, weird little corner cases where it's like, oh, well, that's a fiber channel forwarder and it's got fiber channel as well. Or maybe something acting as like an in-between for InfiniBand or some other kind of like, converged networking technology. But for the most part, we're talking about Ethernet ports on a layer 3 switch. We would expect those ports, generally speaking, different operating systems have different defaults, but very generally speaking, all of the ports could be in a single broadcast domain. You know, put all the ports in VLAN 1 if you want, right? Or half of them in VLAN 10, half of them in VLAN 1, split it up however you want, right? But all the ports could be in a single broadcast domain, probably not routed ports by default. Some operating systems might do it, but probably not routed ports. And probably, like we said, the ports default to a VLAN configuration. They're switch ports by default. You would probably not have NAT. You might, like different vendors and operating system versions and licenses might offer different things, but probably not NAT. And that will get you pretty far in the sort of expectations, right? If you're in charge of buying that next piece of equipment and you know that you need to route between these different networks and those different networks, put it between you and the internet, right? Like this is going to get you pretty far for like why you might choose to go one or the other of these. And this is basically today. Now, once upon a time, this idea of a layer 3 switch was extra amazing because once upon a time when you bought a switch, well, you know, still to this day, you've got that ASIC and you're switching in hardware. Packets go in and out at basically line speed, and it's nice and fast as you're switching. Routing used to always be much slower. Routing is still slower than switching inherently because you're having to destroy and recreate that frame header, figure out where to send it, maybe even do an ARP for that first packet that you send through on any given session. But for the longest time, it used to be a lot slower because it used to be that routers always routed in software. It was a CPU running program to figure out where to send the next thing. And a layer 3 switch sort of introduced that idea of routing in hardware. The extra feature basically of routing getting added into that ASIC to be able to route in hardware and sped things way up. Still a little slower than if you're just sending it out another port without changing much, but much, much faster. And so the original layer 3 switches offered limited routing functionality, but fast routing. Like a long time ago, routers got ASICs too. Certainly any kind of like industry, enterprise routers you're going to buy, almost definitely going to have an ASIC in there to route in hardware as well. So that distinction did exist at one time, but not anymore. Gosh, and I suppose the last sort of piece of it for thinking about why you'd pick one of these one over another comes back down to the topologies we've been talking about, right? So like our classic 3-tier here of having access and distribution and a core router, that sort of classic idea, that was because you wanted to switch everywhere you could and route only where you had to because routing was slow. And so you would have as much as possible on the same network as each other to be able to route, to switch mostly, and then send stuff up to that core router if you had to. Let's put it in here. What do we say? Access distribution core. And because there was such a penalty on routing, and also because routers were much more expensive, generally speaking, you just didn't route unless you had to. But this idea of a layer 3 switch, a switch that can also route, well, that opened up a lot of possibilities, if nothing else, because it is very, very likely that if you're buying some enterprise level switch, it's probably a layer 3 switch. You could probably already route on that thing you already own. Not for sure. Depends on when you bought it. Maybe you can get into some licensing capabilities, but pretty good chance, right? And so this idea of routing being faster, first off, of being in hardware, though, hey, routers do that too, but also being more available on the stuff you already had, meant that your core didn't have to be your router necessarily. It might actually be a switch, and then there's a router that connects past that between you and the internet, right? But the routing can move farther down. Maybe in the distribution layer, maybe at the access layer is where your routing is happening. Yeah! And as that routing moves farther and farther down, closer and closer to your hosts, it means that you have layer 3 decision-making routing protocols that we haven't really gotten into, like OSPF, BGP, EIGRP, that can be used for traffic selection So that instead of using spanning tree to block whole redundant paths and just hold them in reserve, instead, yeah, you can have a whole bunch of different paths and have that routing protocol select the path through the network. And that opens up a lot more possibilities. So this idea of having a layer 3 switch, a switch that can also route, and that the stuff that you're already buying as switches probably can route, opens up additional topologies to say that you can have those redundant links that aren't even just like spare tires, but you're using them all the time, just additional paths. Okay, and so what does that actually look like? Like when you're deciding what to do? Well, let's imagine that this is whatever campus environment, and I'm gonna get rid of this idea of this one being our only router or whatever up top. Whoop. There you go. Still access distribution core, this idea here. But let's say that we're routing at our access switches, right? We've got a whole bunch of computers attached down here. Hang on. 1980s computer go! And let's get some more of those. And watch them multiply. This doesn't exist. It's behind me. What do I do? Okay. All those computers are back there. And for them, they are on whatever VLANs. Now, this we got to be a little bit more careful, because if we are routing everywhere, it does mean that suddenly, like, VLAN 10 can't be like, you know, on this access switch and this one and this one and this one. Not if we're routing everywhere. Now those VLANs are only going to be on those switches. So that does introduce some limitations. That is potentially a downside. Okay, but let's say that all the computers over here are in whatever set of networks, and their default gateway is on that access switch that's right there. Default gateway is the first router you come to. Well, so maybe they're all in, pick a color here, maybe they're all in VLAN 10. Yeah, and VLAN 10, being the broadcast domain that they're on, well, what we can do is we can put an IP address on VLAN 10. Yeah, back when we were doing the interfaces, right, we put an IP on an interface, on a port, and now that port was a routed interface. Well, we can make a VLAN a routed interface. Yeah, and literally it would look like, I'm just going to type it in up here, it would be something very, very, very much like, different operating systems are different, config, terminal, right, and interface, VLAN 10, or whatever interface, whatever VLAN, and then IP address, I don't know, 10.0.10.1/24, or most Cisco's will make you do 255, 255, 255, 0, same thing. And then press enter. Exit out of that interface, and then go to whatever ports, interface, range, ETH, and then, you know, depending on the exact switch model, there'll be different ways of calling it out, but maybe something like 1/1-1/, I don't know, 15. And switch port, access, VLAN 10. Boop. Exit. Oh, spanning tree, port type, edge, spanning tree, BPDU guard, enable, exit, you know, the good stuff you'd normally do on your ports. Okay, and now all of those computers over there, or phones, or, I don't know, IP cameras, whatever, they are all in the same broadcast domain as each other. And maybe I got like 20 different VLANs on there, but like, you know, different devices are in the same VLAN as each other within those different broadcast domains. Okay, and on each of those VLANs, I've got an IP address set up that acts as the default gateway for all those hosts. Well, that's just one more IP address in that broadcast domain. The switch itself has the IP on that VLAN, and it's inside the VLAN as well, inside the broadcast domain. And then when they want to route, well, if there's two different VLANs on there, pick a different color. I don't know, let's put one of these, I only put 3 computers here, but let's say another one is in VLAN 20. Okay, well, like I said, I could have an IP address for VLAN 20 as well. Interface VLAN 20. Oops. And IP address 10.0.20.1/24. Third octet doesn't have to match the VLAN number or anything. It's just often convenient. And then go and put whatever ports on there, right? Okay, now when these computers want to talk between each other in that VLAN 10 and 20, well, they go to their default gateway. And if this is a layer 3 switch, we just route between the VLANs. Yeah, VLAN routing between the VLANs. Cisco will often call this SVI, switch virtual interface. It's just an IP on a VLAN. Just a fancy way of saying IP on a VLAN. Well, awesome. And now we'd be routing between those VLANs here. Well, what about this link between access and distribution? Let's label this. Let's say it's like, I don't know, port number... it's port number 24 on our access switch there, and it's port number 1 up on the distribution switch. Well, okay. Here is likely where I would go back to putting an IP on the port. Very, very likely. And I'll probably repeat this in another one down the way, but very, very likely, the reason you would put an IP on a VLAN is because you want it to be the default gateway for a bunch of clients. And very, very likely, the reason you would put an IP on a port is because you're making a network just to connect those couple of routing devices. Yeah, and so if the distribution switch, if we're already routing on it as well, yeah, then this could be some tiny little network. And so back over here on my pretend layer 3 switch, I'm running out of space. I'll just wrap around. I might go to, port number 24 there, interface. I'll just do int. ETH, I don't know, 1/24, and put an IP address on it. I don't know, 10.0.0.1/30. I've just broken your mind. /what now? We're going to deal with this later. But the short version is a /30 network is a teeny network with 2 usable addresses. In this case, it would be 10.0.0.1. I didn't do IP address. That's better. IP address 10.0.0.1/30. 10.0.0.1 and 10.0.0.2 would be the other usable IP address. Yeah. And so here, I would have just put that IP address apparently 10.0.0.1/30. In fact, I'm writing the whole thing here, but usually on a diagram, what you would do is you would write the network address 10.0.0/30 on the link between the two of them, and you would probably just come and say .1 for that port. And .2, 10.0.0.30.2 would be what the IP address I would put on this port 1 of whatever that distribution switch is. Yeah! And now, that's just some other little network. This point-to-point link, this network between the two of them. Awesome. And we can do this on the layer 3 switch of routing between the VLANs by putting an IP on the VLAN and making putting an IP address on that port. Almost certainly, different operating systems are different, but almost certainly put an IP address on that port to act as a little network between the two of them. And this is what I could do with a layer 3 switch. Layer 3 switch is just going to have a bunch of Ethernet ports, and it's the thing I was just using anyway, right? But now those bunch of Ethernet ports with those VLANs on it, I can route between them. I can probably still put IPs on ports. And then I would be able to run some kind of routing protocol that we'll get into down the way, like OSPF, open shortest path first. EIGRP if it's Cisco. ISIS, not as common, but often used in internet service providers. BGP is very, very, very popular in, yes, internet service providers and data centers and more in campuses. And these are all just different routing protocols that we'll talk about. And that is to say they're protocols that share networks and network reachability between routing devices and layer 3 switches. Okay, and the reason you probably wouldn't have a router doing this is because a router likely has fewer ports. It's probably more expensive, and the ports it has are less likely to be as fast. Gig is still definitely a possibility, right? But in a modern data center, 10 gig has become slow. 25 gigabit Ethernet is the new baseline slow connection to a server. 100, 400, 800 gigabit Ethernet exist in the data center. Yeah, in campus and a lot of environments where our clients are, 1 gig is still fine, but 10 gig would be your uplink maybe. 10 gig is getting more and more common though, and maybe 25 or even 100 gig is your uplink. On a router, something sold as a router, 10 gig, like we said, is pretty darn fast. So relatively fewer ports on something sold as a router. Likely to have options for those WAN ports. Likely to have more routing features and fewer switching features. Because you're going to put it between you and the internet. All right, everybody, this continues to be a blast. Thanks for coming out. Oh man, just like always, drop stuff in the chat. I really appreciate y'all's messages in there. If there's something you're wondering about, if there's something you want me to put on the list, if you just want to say hi, drop it on down there. I appreciate it. I'll get back to you, I bet. And otherwise, like it if you like it. Subscribe if you're looking for more. We'll see you next time.
Bring forth the layers. All right, bring it on in. Yep. Okay, on back. That's one. Yeah, go on, keep loading them up. That's two. Yep, keep it coming. That's three. 3 layers. Now we're out.
Please take the third exit from the roundabout.
I said route, not route.